The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, thanks for joining this webinar. I hope that you can hear me well. If it's so, please could you type in the chat area that you can hear me so we don't have any audio problems. Okay, I see that you can hear me, so that's fine. We still have 1 minute to go. We'll wait for other people to join this webinar and then we'll kick off. Okay, so let's start this webinar about the very new integration of a software called Dynamo to Alias 2019. This session, this webinar will be recorded. The recording already started, so don't worry if you want to revise this webinar and to listen to it and to see it once again. It will be later on sent to you with some link. My name is Andrzej Samsonowicz. I'm with Autodesk, and actually, my background is I'm an architect, and for some years, it's already some time that I'm working with computational design at Autodesk. I also learned, Grasshopper and Autodesk software Dynamo. So, and I have a quite deep experience in both software. And even though I come from, let's say, building industry, I had a lot of great opportunities also to work with automotive industry and promote Dynamo amongst different companies. Dynamo is already existing on the market for some years, but till now, let's say till beginning of this year, it was rather a building industry software focused. But this time we are implementing Dynamo also to Alias, which is a leading automotive industry tool. And very shortly, we have just 1 hour, so I have to be. I have a lot of things to show you, so I have to be very brief and concrete. But this is the agenda, so I'm going to explain you what is this mythic magic Dynamo and what is computational design. And above all, where this computational design can help you. So what's the benefit? What's the reason I'm presenting this to you? So where computational design and where Dynamo can be used in things like wheels and rims, in front grills, and in designing them, of course, like in a creating of complex patterns, on a single surfaces or even on poly surface, which is of course much more complicated, but nevertheless I will show you something about that. Yeah, and then also what are the kind of the general benefits of investing your time in learning this fantastic software. So what is computational design? I'm not gonna do any reference to building industry and to architecture because it would take a lot of time for us, and I want to focus on Alias and Dynamo integration exclusively. But some introduction to what the computational design is, of course, is necessary here. So in relation to design, computation involves the processing of information and interactions between elements which constitute an environment. So you are, with computational design, you are creating a kind of environment within Alias, and you will see soon what does it mean. Computational design provides a framework, so the area for negotiating and influencing an interrelation of both internal and external properties with the capacity to generate complex order, form, and structure. By combining the principles of computational design with Alias modeling tools, a fundamentally new potential of Alias as a design software is uncovered. So, and the answer, of course, so the tool of which is working in the field of computational design is Dynamo. So what is Dynamo? Dynamo is a platform, it's a software, it's a separate software which runs on the top of Alias, which is based on visual programming. So in this webinar, I'm going to show you a little bit how to make scripting, I'm going to prove that also you can become a programmer, okay? And anyone can become a programmer. Actually, and yeah, this idea came originally from, let's say, again, architectural industry, in which architects desperately needed this kind of a easy way to start programming, to introduce, to democratize programming in their industry. And it became possible. So so basically, visual programming and computational design became. So this democratization came true because actually these people that started to use it actually didn't have, let's say, to become a fluent user of visual programming, you don't need to have any very deep programming knowledge, experience and knowledge. So you don't have to have a PhD at the university or technical university in programming. You need to have an open mind and to follow the logics and basically of course, and know a little bit of maths, but not too far. Dynamo is of course, is again a computational design software which is with the interface using visual programming. Dynamo is integrated with Alias Auto Studio Surface and Concept from the version 2019. It was not possible to work with Dynamo and Alias before the version 2019. What is also very important is that actually the geometry created by using visual programming, by using Dynamo in Alias, will be actually native geometry in Alias. So the great thing about this, so the biggest benefit, when I'm gonna list it out at the end of the webinar, but the biggest benefit that we are having when integrating Dynamo with Alias, that we are introducing a visual programming within the Alias tools. So I'm gonna create the Alias native geometry within Alias. I'm not going to import any other external files. I'm going to use Alias API to generate geometry in a very, very specific way, unusual way. As you could see on this screenshot on the right-hand side of my screen, of my slide, you can see that Dynamo is, you don't have to have, so Dynamo became the part of Alias, so like physically part of it, right? So you have it already together with the software, so you don't have to have any other, let's say, installation. It's in there, it's embedded within the software. So this is a really, really great benefit. So you don't have to have any external, let's say, so it's embedded, it's inside. I'm going to show you very, very quickly. I'm going to present you, in this webinar, you're going to see some very short videos, but I'm going to also present a lot live. So you also have a feeling of how, let's say, how that works without any, let's say, cheating, without any, accelerated videos. It will be really, some things will be really like live. So I'm gonna start with this data set which you see on the screen. I'm gonna go here on the left side to transfer, and I'm gonna click on this icon, Dynamo icon here. Okay, as you could see here, it ran, and here I have my Dynamo window already running on the top of Alias. If I hit on new, here you can see that, okay, I'm not gonna, this webinar is not really a training, so I have to, some things have to be explained very, very briefly. We don't have time here to to discuss every little detail and everything. You will have a lot of, I see that you were a lot on this webinar, so probably we will have very difficult time at the end to to answer all the questions. But nevertheless, I promise you that you can mail me with the questions that will pop up after this webinar, and we'll try to with my colleagues here also to respond to all of them. So don't hesitate. I know that you will have a lot of questions after this webinar, and we will really do our best to answer all of them. Right now you are more than 100 on this webinar, so it'll be really, really difficult to handle and to manage Q&A at the end. So let me very quickly explain you a little bit how it works. So you have basically, we have environment here in Alias, okay, and here we have like a duplication of this environment here in Dynamo. So what you have to also be aware is that also the navigation is a little bit different than in Alias. So for example, right now I'm clicking just a right-click mouse on my mouse, basically right-click. So you have to also take in account that also the navigation will be slightly different between Dynamo and Alias. This is all due to the fact that Dynamo comes from the building industry, from architecture industry, and that's why there are some reminiscences of this fact that we are sharing the same platform, automotive industry and architecture industry. So what I'm gonna do here is I'm gonna scroll up to the very top, and I'm gonna select, I'm gonna expand the tree called Alias, and here I can start selecting from Alias elements directly designed conventionally in Alias, because of course I don't have to model everything in Alias, in Dynamo, and push it to Alias. You can have very, very comfortable hybrid approach with things that will be, partially created with the conventional tools in Alias, and then somehow, enhanced, tuned with Dynamo. So what I'm gonna do, I'm gonna hit on select here. Please note that Dynamo is minimized immediately, and here on the left, basically on this window, if you don't see it, just double click again on Dynamo icon here. I'm gonna select some objects. Here you can select between objects as which in our case will mean surfaces, CVs, COCs, and edges. So I'm gonna this very first example, I'm gonna use objects. I'm gonna select my surface, and then it's very important that you have to click on send. Okay, send. Now you will see your surface selected from Alias in Dynamo. However, you have to also be aware that this geometry already exists here. If I move my cursor here, you can see that there is a surface here already selected by this node in Dynamo. And then to see that surface, I need to somehow, change the visualization mode from script mode to geometry mode, and hit this icon so it basically fits to all, right? So I can see in Dynamo this piece of geometry, this piece of surface that has been selected in Alias, right? Now, I owe you also some explanation of what visual programming is, of course, right? So because my introduction was very, very, very brief at the beginning. So basically, it's all about creating I have this list of icons they are called here in this nomenclature, they are called nodes. So each icon is actually a node. Each node should have an input and output, and all the thing like all the idea that stands behind the visual programming is to create a logical flows of these icons, because you can connect one with another with a wire, and this connection makes logical connections, makes an effect. And this I'm going to show you something in a couple of seconds. So I have this surface and I want to create some points on the surface. So I'm going to select a node which allows me to create points on a surface. Again, unfortunately, I cannot explain you every little thing that I'm doing right now. You have to just trust me that this makes sense. Okay, but here what I'm doing is I'm just creating two lists of numbers between 0 and 1, 10 numbers between 0 and 1, and 20 numbers between 0 and 1. So it looks like this, right? So I have between 20 numbers between 0 and 1, okay, 20 numbers. Lacing cross product, okay? So what I'm doing now is I'm creating a logical flow, right? Because I'm selecting a surface and then I'm adding to that surface, I'm connecting this node with another node, which is actually putting points on that surface. So in Dynamo, I can create very, very complicated in terms of sophistication, let's put it in these words, very complicated flows of data, which will be always parametric, right? So I never lose parametricity between them. This is super important because I am creating exactly from one of these first slides I showed you, I'm creating an environment here, right? So it is all about creating a seamless parametric flow of data, okay? Logical flow of data. Every single element here is controlled and needs to be controlled logically, right? So what I'm going to do next, I'm going to also show you something like I'm going to create a normal at point, which means I'm going to create a vector or direction on that point on that surface. So actually the direction showing perfectly orthogonal to the surface, okay? What I'm going to do next, I'm going to also create a circle with a center point, normal, and I'm going to also introduce some radius, let's say 15, okay? So in this step, I have created a series of circles. This is super simple, of course. Very, very, here no sophisticated things has been done, but you can see already that I have started with the surface, and I came back with or at the end I have circles with certain radius. Okay, but then I have to show you something very, very important right now, because what you can see is that this geometry, these circles which I just created, they can be baked directly to Alias, and I'm gonna do it in a moment. Okay, so this geometry will reappear on our surface very, very soon. But let me do something more, because what I'm gonna do also, I'm gonna just select it, copy and paste. I'm gonna introduce two sliders. Sliders are nothing else but this kind of slider, right? So this kind of way to introduce more, let's say, freely with freehand a number. Instead of typing in like 1 or 2, I can also introduce a number by just introducing it more freely. Okay, and I'm gonna create a point, okay, which is somewhere. You can see it here. If I select a node, you can see also the highlight in blue somewhere in the middle. And of course, as you could see here, if I start moving the slider, the point moves in different directions, right? Okay, so, but this is just a point. And what I'm going to do next, I'm going to actually measure what is the distance. I'm going to flatten these points. Okay, and so what is the distance between my point, which is moving here, and every single circle, the center of every single circle. He gives me some list of numbers. So they're distances, nothing else but the distances between my single point and the centers of circles. Okay. Okay, so what I'm going to do next, I'm going to somehow modify this radius of my circle, okay, by the proximity of the point. This point is a kind of, let's name it attractor, okay? So the distance of this point will somehow affect the circles. So if I go and say, okay, I want my distance to be a radius, then it will become a little bit too big, right? Because of course the distances are very big, and radiuses probably I need them a little bit more smaller, but I want to maintain the proportion. So I'm going to divide my distances by 50. This is a little bit maybe too much. Let's put it maybe 30. Oh, and now what you see is that I have started with selection of my surface, static surface in Alias. And by moving my point attractor on the surface, okay, I dynamically change my drawing. Okay, and this is the best examples and most, let's say, illustrative example of what visual programming is, because I have created here an environment, right? And this environment is all, let's say, coherent, right? Because I have my surface, I have my set of circles which change the radius depending on where my point attractor is located on that surface. And now look, because I want this to be, I want to highlight the fact that we have this integrated deeply with Alias, because it's not just that I'm selecting a element from Alias and then I'm creating some geometry, even though it's still is already environment, but I have to save it before. Okay, and now I'm gonna hit on Bake to Alias. Okay, and what this does is, look. Oh, wait a minute. Oh, here. Okay, so I have immediately my result in Alias. This is the geometry which is using, the Dynamo is actually calling the API of Alias. So basically, it's looking inside the tools which Alias has and using them to recreate that geometry. Okay, not exporting anywhere. No, there's no any other, let's say, file in the middle. It's being pushed directly here. Okay, but then look, this integration is really, let's say, sophisticated, because now I want to let's say select an object here. Okay, I'm gonna select the surface here. I'm gonna turn on the CVs. Okay, I'm gonna select some of these CVs, not all of them, just not to overcomplicate, but let's say I'm gonna select this guy here and this. Okay, I'm not gonna select everything, it's not really important now, but what is important is that if I sorry, I have to select it again. Okay, even these two are okay, because what I'm gonna do now is I will move them. Okay, I'm just modifying the original surface, and what happens, look, I don't even have to run Dynamo or anything do there. This geometry will automatically update to a new situation, okay? So I have really smooth and seamless connection between my script, my environment, and my source geometry, which I have selected in Alias. Okay, so let me go back to the presentation, to the PowerPoint. I hope that you see it and everything is all right. I'm just gonna look on the questions area. Okay, I see that everything looks fine. Okay, so after this first demo, I'm gonna go to the section how does computational design can help. Okay, so you already see probably some good applications in your daily routine work, but let's summarize them. So especially it's important when you want to quickly explore multiple design variations, even before they become, let's say, the final ones. Okay, so this is like super fast way to for the conceptual design. For the conceptual design of things like, parametric patterns, wheel rims, but you can think about using it almost everywhere. And definitely it improves the transition from the concept to design, because you are creating a parametric environment. Okay, so you're not losing anything in the middle. And again, because you're creating this, let's say, this environment, this framework, parametric framework, you can focus more on design and less on reworking and less on manual things, right? And then you can maintain early design intent throughout the design process, so you can really avoid situation which you're losing your original idea somewhere in the middle, because you are having everything parametric, right? So you're having this in the code as a script from the very beginning. So just to summarize, right? So rapidly test, iterate, and study multiple design options in less time. Solve complex geometric problems, because sometimes in Dynamo with visual programming, it's faster and easier to generate complex geometries, which would normally by hand would take a lot of time, right? You can automate repetitive tasks for more precision and speed. You can generate sophisticated design from the simple data and logic, and you have ability to work directly on native geometry in Alias, so you're not importing anything from anywhere. It's everything happening in there in Alias. Okay, let's start with some nice examples. I'm gonna start with wheels and rims, okay? And I'm gonna present you two examples very quickly again, and this will be live on the product. So I'm gonna come back here to the wheel. I'm gonna select this wheel and pick nothing. Nothing. Okay, object. I'm gonna isolate it. So we are more comfortable when selecting things. What I'm gonna do here, of course, I'm not gonna create any script from the beginning right now, but I have series of scripts which already prepared for this. So I'm gonna start with simple wheel. Simple. You'll see the geometry in a moment. It will not be a okay. Now the script may look a little bit frightening, but don't be like, really. This is the great thing about visual programming, is that it's all very descriptive. It's very illustrative, so you're not losing yours. It may look at the first glance, I agree, this looks very weird, like a spaghetti, all these wires, and sometimes it's really difficult to to understand what's the intent. But once you will invest in your time in learning it, you will see that this really later on it's really easy to read exactly what is written here. Okay, so you don't have to, like, if you compare it with a conventional code written in Python or with C++, this is so much simpler. Okay, and I'm gonna select from Alias. Okay, here, go back, select, and here I'm gonna very quickly, again, edges, right? I'm gonna select sorry, objects again, edges, select, I have to select all these edges of the wheel to have a background, of course. Okay, nearly done. Send. Okay. Let me have a look on this now in Dynamo. Okay, I have 5 elements selected. I run it. Of course, my script is already prepared, so I'm not gonna do anything here, just to show you the result. But in a first step, I'm just creating of course, the parametric surface of my wheel. It's a revolved surface. But of course, here what happened? There's a lot of things happening. For example, somewhere here, I already decided that the spokes of my wheel will look more or less like this. And then I have decided that if they look like this, then I have created, of course, there is a lot of like Boolean operations here, but then I have decided that they may look a little bit like this. So these spokes are actually also rotating. I can spoke rotation change, right? I can, for example, decrease this rotation. So I have this basically all this parameterization at any time, right? And once I have decided, let's say, in a more or less, this is just in the middle somewhere. But if I decided that this is basically satisfies me, I can run it. Okay. It may wait a little bit, but then if I turn off the visibility of my original surface, and then if I go back to my solid union here, you can see that I have my geometry created in Dynamo. And of course, I could now continue to, you can imagine about, for example, I can increase the number of spokes, like let's say 12. Okay, I can even decrease and run. Of course, this is a lot of operation for the computer to be done, so sometimes it takes quite a lot of time to generate it, or even sometimes you can also encounter a situation in which too many spokes probably, so so the geometry which results is probably not really probably they started to overlap each other, so it was some error probably. But then, for example, I can decrease, for example, the depth of this element here. I can increase and decrease the ratio, so you're going to see it in a moment. Here, run started, so I'm deciding also in Dynamo when I want to execute my script, which also can help me a lot to to avoid some situation in which the script can also contain errors, which I did, right? So it can also crash for this reason. But then, for example, let me increase the ratio, so which increase or decrease the size of these elements. Okay, so they are a little bit thicker probably. And now, of course, I have at the end, I have created this geometry, this parametric geometry, which is again solids. They are solids, right? And here I'm gonna hit and Look, it takes really a moment to bring it back to Alias. Of course, I could keep this connection all the time, but then it takes a little bit more time to execute that. But here you can see that I have my wheel rim already done, right? And if I maybe highlight it, right? So you have it immediately in Alias with Alias geometry and so on, right? Okay, let me show you another example of a rim, and this will be really, really very new. Okay, you have to apologize me. I have to select these edges again, but it'll be fun. So I'm gonna open a new script. Okay, this is gonna be wheel Tspline, and by the way, the great thing about Dynamo is that we also have a Tspline technology embedded inside Alias. And the great thing is that actually, well, I shouldn't say great, but if you run Dynamo for the first time on Alias and you want to see your Tsplines tools, you have to go to settings and strangely go to experimental and turn on enable Tspline nodes requires relaunch of Dynamo. It is in experimental phase. It's not easy to be used. However, the results are really, really interesting and really spectacular, I would say. I'm gonna again start selecting from Alias. Unfortunately, I have to select again the okay. On these edges. Okay, send. 5 elements selected, and now I have okay. Some things here are disconnected, which is great. And what you're gonna see now here is that there are some things will happen first in Dynamo, actually not in Alias. So I'm gonna click here, and as you could see here, I have imported some, let's say, geometry created using the Tspline technology in Dynamo. But just to facilitate the script, this element has been created as a separate file, and this element looks like this. Okay, this is a Tspline geometry created in Dynamo, and then exported as a separate file just to simplify the script. Okay, and as you could see here, there is also a surface beneath that geometry. Okay, and what I will do here is, let me turn on this. Okay. Oh, and so what happened here is, I'm going to show one more step. Show it to me. This. Okay. So basically, what you can also do from the let's say surface created with Tspline technology, you can extract edges. Okay, and then I can take these curves. Okay, and actually with the script, I can take these curves and I can actually also take the surface, okay, and somehow transpose, okay, these curves in relation to this rectangular surface, okay. I can transpose them into another surface, okay, kind of curved, twisted surface. And now I can, and by the way, this is nothing else but a set of lines, okay? Flat, like a list of lines, nothing special. Oh, well. But then if you have basically these curves, original curves has been transposed from one surface to another in 3D. So what I can do here, I can actually take that original geometry, which looks a little bit like a bone, and I can, let's say, twist it and adjust it to the new surface, which is here on this wheel rim, okay? So what I can do next, I can just somehow perform a series of operations. Okay, be patient. This will list super fast. Paradoxically, as for the complexity of the surface, it's super fast. Right now, Dynamo was faster. It already calculated the geometry, but the graphic cards is still working, and sometimes you have to be aware that so graphic cards sometimes in your computer graphic card works slower than Dynamo. So what this actually created here is this kind of a super complex geometry, which probably no one would even dare to make it manually, but nevertheless with Tsplines it is possible, and it was just created based on some lines, basically some set of straight lines. Okay, and now again I'm gonna do the same. Look here, and by the way, one important thing, Tspline created in Dynamo needs to be, there is a special there is a special node which converts any Tspline into polysurface. While having a polysurface, I can collect also these elements, for example this and this, and I can collect them into one single list, and I can now take it and bake it to Alias. Okay, and this is really great because I have this geometry in Alias here. Okay, and of course if I continue to modify whatever, I don't know, if I change the size of the wheel, of course this geometry will again update to the source geometry. Okay, all right, so this was an example on the wheel rim, just to let you know how far you can go with the geometry creation with Dynamo. And what I'm going to do next, I'm going to close this, because on the I'm going to go further with the presentation. I'm going to present you again a little bit about what can be done in terms of the front grills. So front grille can be it's a good example which explains how to also deal with the patterns, right? Because it's a pattern on the surface. So again, I will go back to my Alias file. Okay, I will turn on everything because visible. Of course, these things have disappeared because I didn't save it, and I have closed the script, of course. Visible, everything, of course. Yep. Okay. So what I'm gonna do here on the very, very bottom of this data set. Oops. Okay, sorry, I'm not really an super Alias expert, so you could probably immediately recognize that, but it's not important in this case. I'm not showing you Alias, but Dynamo. So yeah, let me isolate this display hide unselected. So I'm gonna work on my surface here. And again, I'm coming back to Dynamo, open, and I'm gonna open hexagonal pattern then. So of course Dynamo has its own, let's say, has its own file, but the thing is that has its own format, of course, as well. But the great thing is that I don't have, and it's saved separately on the hard drive. It's not saved within the Alias file, right? So it's remember to It's important to remember. And also what is, but the thing is that of course I do not have to import any external geometry. I have to somehow read the script which is written inside Dynamo file, but it's all basically. Okay, so the next thing I'm gonna do here is, again, I'm gonna select you a the border of this surface, and again edges, right? Here, here, here. Okay, send, go back, select object, and selecting also the surface. Okay, so I have selected and the edges and also the surface, the main surface of the front grille. Okay, there are some, of course, there's some I have disconnected this the script, the flow, this framework, this environment, just to also see what happens in some certain step. Okay, so I can run it, and because I've forgotten to, okay, there is a problem with, I forgot to set send, of course, or I click it but not precisely. Okay, the thing is that what the script creates for me is a uniform hexagonal pattern on this grille, right? And then what I can do here is I can, of course, again measure what is the distance, for example, from this hexagons to the border of my surface. Okay, this is, if I hit here, you can see that I have extracted the polycurve which describes basically the edges of my surface. Okay, then if I substitute this with this, actually I'm gonna do this, right, and run it, what this script calculates is actually he's doing also the offsets, and look at this, right, because he's basically calculating what is the distance between the center of each single hexagon, right, and gradually changes some geometry of them through the let's say as soon as they get closer to the border of the surface, right? I can even here, increase this, let's say, amplitude of the change, right? It's all stored in this, let's say, in the script, right? In this environment, in this framework. I've created a parametric pattern, right, based on the surface created in Alias. And now, by having this, I have already a lot of information here. And for example, I can think about even creating some more advanced, let's say, geometry based on these hexagons. I'm going to extrude them, but in a very, very specific way. You see that some operations take some time. It's all due to the fact that, maybe I will advance your questions, Dynamo is using only one thread of your processor, and so far we have to deal with that. Yeah, it's using basically one thread of the processor, so it is not multi-threaded technology yet. One more, I have calculated all these scripts are executable within less than 1 minute for sure, so I'm not afraid of what will happen in a... Oh, okay. Still, sometimes the geometry, it's here, yeah. So basically, again, I have this geometry which is basically extruded. So hexagons has been extruded along the, let's say, the direction of the car. Let's put it in this way, right? So this, in my case, I think it's an x-axis, and of course they become smaller once they grow, right? And this time it's a set of surfaces, it's not even a solid. Now I can go and again hit and run it and bake it to Alias. So paradoxically, baking to Alias will take less than generating this geometry in Dynamo. And here it is, right? If I look at it from the side, you can see, maybe you can also turn on the visibility of the entire dataset. So layout is window display. Visible. Okay. Right. Okay, so let me also show very briefly another example. However, in order to show you this another example, let me kill it what he did in Alias. Because there is also a nice example of Tsplines using basically front grille made with Tsplines, which I think is worth of showing. Yeah, it's still calculating something. Maybe I will stop him now. Yeah, just to accelerate. I know I shouldn't do that. Especially during the webinar, but just to accelerate. Okay. By the way, it's also a good lesson for you because you can see that Alias will not crash. Basically, what I'm trying to do right now is to wait a little bit more. So you're not losing your work actually in. Yes, here it is, right? So I have crashed Dynamo, but of course the geometry which I've created is still here, right? So let me maybe again go to surface, and I'm gonna isolate the surface again. Okay. And I'm gonna show you the last live example. I'm gonna open a hexagonal pattern with Tspline. It's gonna be very fast, even though it's Tspline. To select again, I'm gonna also again do hexagonal pattern on it. Oh, forgot this. Send, right? Then select, and select and send, and then object select here and send. Okay. So again here also I have interrupted my script here somewhere in the middle. It's doing again the hexagonal pattern on parametric hexagonal pattern on the front grille, but with this difference that I am gonna do something like I'm gonna build some structure made of lines on the top of it, which looks like this. Okay, so basically these are, if I maybe highlight one of these, Okay, so basically I'm working with this kind of geometry, which is this kind of hexagon made with it's a wireframe model, basically, right? So what I'm going to do here is I'm going to create Tsplines out of it, Tspline surface, which again, building it sometimes takes quicker than graphic card is able to handle it. Okay, so he basically, what it does, it converts this kind of wireframe structures based on hexagon into these strange little circles. But since my hexagons were all touching each other, right? Now I can convert it into a so-called combined by T-spline surfaces and then weld coincident vertices, which means that I'm going to create a one continuous surface out of these things, out of these openings. Again, sometimes graphic card is not following the processor, but this will take, I'm going to turn it off so you can see it better. Okay, so here I have my strange pattern on the front grille, made continuous surface, right? Made out of the hexagons. And this thing is going to be converted again into polysurface and then pushed to Alias. Okay, and then back to Alias, run. And here it is. Okay, let's turn it off. Let's highlight it. Okay. Okay, so let's go back to my presentation. I will show you one more video with patterning. This is again the same data set. It shows one more example of what you can do in terms of the patterns, not only on the front grille. Again, here you have at least two different surfaces which I'm selecting. Then there are triangular polygons created on that surface. Then some operations like you extract the you find the center of the polygon, then you extract some curves, and then based on again attractor point. So based on some location of a point in the middle of this glass of the surface, there are some things happening with these polygons, like they rotate, they change the size, so they change the scale, and you can play with before you generate a surface or anything else or a patch. So yeah, so you have this patch here, and then you can intersect it with then in the middle of in time the script is also thickening the pattern, and then you can turn on the let's say the perforation, the physical perforation in that surface. You can think about much more different use cases, of more sophisticated and more mathematically programmed, like the spirals on the left. You can think about different effects that Attractor makes on the geometry which stands around, how it changes the geometry, and you can apply this approach, this philosophy, for different speakers or diffusers and so on. Then I don't have time, but it is also possible to apply a pattern on a polysurface. I admit that this is a really complicated and advanced, let's say, operation, but nevertheless, it is possible with Dynamo here. Unfortunately, I don't have video to present that, and I'm not going to also risk to present it live because it takes time. Okay, you have to trust me and you have to believe me. But it is, as you could see here on the screenshots from Dynamo, you can also apply a polysurface on a pattern, complex patterns on polysurfaces. All right, and here I will show you the last video presenting also another example where Dynamo can be used to create complex geometry for the front lights, for example. Oops, it was paused. Yeah, so but the principle is the same basically. You can increase. You have all the objects are parametric, so you can increase, the count of the LEDs. Right, and then bake this geometry inside Alias, and again. Yep. Okay. So what are the main benefits at the end? Just to summarize what you've seen today, it's an excellent tool for for quick exploration of very complex design concepts and to verify this design, because remember that it's not only the geometry. If I create a pattern or an openings on the surface, I also Dynamo can tell me what's for example, the ratio between, tell me the number, right? So what's the surface of the originals, what's the area of the original surface, and what's the area of openings, right? So it's not only actually the geometry, it's also the information that you have within your script. With Dynamo, we have connected parametric and logic geometry. There is no any discrepancy. It's all controllable. Of course, it's very demanding because you need to put a lot of, let's say, the initial, let's say, information in order to get this logics, but it pays off really, and it's seamless workflow. Really, Dynamo is integrated with Alias, and you have no need of any third-party software to to import external files or anything like that. Of course, you have Dynamo file itself is a separate file, but it's not a geometry. It's this logic stored in that file, right? Now, and of course, this can be used by anyone at the end. It's in building industry. It's used even by the general contractors. So it's really for architects and also for the people that you would never expect that could use this kind of tool. Again, I see on the question pane that there are a lot of questions. Now I'm going to show you something also where to get some information. But I see that there is one interesting question which I'm going to answer immediately. For the rest of the questions, please mail me. I will we will collect all this information, most relevant questions, and will mail you and answer your questions. But nevertheless, I would like to stop on one. There is someone of you asking if there is anything like community of users and let's say some, to be better said, if there is any way to get some extensions for Dynamo, some let's say extra plugins or some extra functionalities which do not have, which Dynamo out of the box do not have. And the answer is yes. If you go to packages and if you go to search for package, here you can look for some additional functionalities which are being created, which are basically created by the community, by users of Dynamo, by the users like you. And these extra tools are being published here, and you can download these extensions for free. Okay, and they can extend sometimes dramatically the standard use of Dynamo, the standard tools of Dynamo. I'm not going to list now all of them because there's a lot of them, but nevertheless, it's very, very. Some of these packages really save a lot of time, right? So because of course Dynamo has a lot of nodes, has a lot of functionalities, but let's say sometimes you need to, let's say, get use of something which other people have done. Okay. Now, what I want to also emphasize is the some important pages, so you can consult and Dynamo BIM. So the most important, if you want to start learning it and exploring, probably the most comprehensive source of truth, source of knowledge will be Dynamo. There is a homepage, dynamobim.org, and this is the place where you will find, if you go to Learn section, you will find a lot of information, a lot of videos, and also some comprehensive, you have like dictionary of what these nodes mean, what can they do. There are some tutorials, some resources. There is also a forum where you want to, if you want to ask a question and you don't know how to make some things, how to proceed, you will find a lot of information here. There is a blog dedicated to that. There's a lot of things related to Dynamo. By the way, if you go to the homepage dynamobuilds.com, you'll find that there is a lot of that Dynamo is changing, and there is a lot of, let's say, daily releases. Okay, you can follow and you can see how Dynamo is being basically changed. However, right now, for today, if you downloaded this version of Dynamo, this kind of additional information for you. This Revit is for Revit, okay? So Dynamo Revit 2.1, okay? Right now we cannot run it on Alias, but just to let you know that this page exists, and you can follow somehow, how Dynamo is being basically developed. And then of course we have several channels on YouTube where you can learn, where you can see some videos and step-by-step tutorials on how to do certain things. I can recommend you, I have put it here some time ago, some five videos where you can really step-by-step follow how to do a parametric pattern on a surface, on a single surface. Okay. Okay, so I see that some of you, I see on the question pane that some of you have not get my email. So if you let me type you I'm gonna type in here in the chat area my mail. So if you want to if you for some reason you will not get the link to the recording, please do not hesitate to contact me. I will send it to you. Okay, so this is my email address, and okay, so we are running out of time. I'm really glad that so many people have joined this webinar. I hope that it it was an eye opener for you, so you can really feel the potential of Dynamo integrated on the top of Alias. I hope that you liked it. Yeah, and to the next webinar, hopefully soon. Have a great rest of the day. Goodbye.